Okay, today I'm going to be attempting to drink liquid nitrogen through a straw, and then I'm going to show you what happens if you were to drink liquid nitrogen through your throat and then into your stomach. So I promise you that whatever I can suck up through this straw, I will drink. And I'm not even going to cheat. I'm going to make sure the straw is very cold, the same temperature as the liquid nitrogen, so it won't just heat up when I suck it up and turn into gas. So I have here just an insulated clear cup so we can see the liquid nitrogen in there, and I have a clear straw so we can see what's going on inside the straw. Okay, so first let's pour some liquid nitrogen in our cup. So you can see it in there. So if this were water, it should be pretty easy to suck up through the straw, right? So first I'm going to get my straw in there, cool it down to the right temperature. Okay, so you can clearly see my straw and the liquid nitrogen there. Let's see if I can suck any liquid up. All I get is a bunch of gas. It's very cold gas, hence the cloud of mist. But it's not liquid. No matter what I do, it pressurizes my mouth when I try to suck it. So my straw is cold, so it's not the straw heating it up at all. Okay, so let me try it again with a wider straw so you can actually see the bubbles forming in there. Let me get it all cold first. Try to suck it up. Oh, man. So, you could see the bubbles forming in there. A splash went up and then a puff of air, a puff of nitrogen caught me in the throat. Ooh, that got cold. And pulled off some of my skin. So you can get liquid nitrogen into your mouth, especially when some of it splashes up and then it continues to boil below it and that gas pushes it up through the tube. But it's definitely not a steady stream of liquid nitrogen as you would get sucking water through a straw or something. It's weird, it's like I can feel it boiling up through the straw even though the straw is cold. So the question is, why can't I suck up any liquid through the straw? And the reason is because we're at the boiling point of liquid nitrogen, and in order to suck up something through a straw, you need to create lower pressure in the straw, and the atmospheric pressure pushes it up through the straw. But since the liquid nitrogen is boiling, it's keeping that gap pressurized, and so you can't get a vacuum enough to suck up the liquid into your mouth. No liquid, just gas. And you can actually hear when I suck up, you can hear the liquid nitrogen more rapidly boil in the straw. And that's because I'm creating a lower pressure and that makes it boil even more to try to repressurize that vacuum space in this straw. So this is the same reason why if you try to suck up boiling water through a straw, all you get is water vapor. So I have here just boiling water with a straw that's at the same temperature as the water. And as I try to suck up the liquid, you can see that the water just boils as I try to suck it up. So you could see the water bubbles forming in there as I was trying to suck up the water. That's because as I create a lower pressure in the straw, it makes the water boil even more, and so it can't go up the straw as easily. So the reason why I couldn't suck up the liquid nitrogen is called cavitation. So cavitation is actually a big problem when you try to pump liquid anywhere. That's because when you try to pump it, if you get to a lower pressure than its boiling point at that temperature, then it will just boil in the tube and you can't create any suction. So you can also see cavitation when you try to suck up something too fast through a syringe. So see, as I reduce the pressure by pulling it up, it just boils the water in there and it can't keep the same suction. So that's how I'm able to increase the volume, because the water just keeps boiling. And this is essentially the reason why you can't have an infinitely long straw. You're limited to about 30 feet of how long a straw could be to just suck up water. because you have the weight of that water pulling it down, and you need to create a vacuum to pull it up. And that vacuum pressure is lower than the boiling point at room temperature. And so essentially you can't get any suction because you just start boiling the liquid in the straw. Okay, so first, to see what happens if the liquid nitrogen gets to your throat, I have here a throat. Don't ask who I took this from. Just kidding. It's a chicken breast that I stitched together like Dr. Frankenstein into a throat. So when you swallow, what happens is your muscles in your throat compress together and it takes it down like that. So it kind of is open and grabs some and massages it down into your stomach. And so let's see what would happen if you got a gulp of liquid nitrogen. Let's see what it would do to your throat. Okay, here we go. So it gets through pretty easily. Surprised. So it can get through your throat. I thought it was just gonna freeze it solid, but it looks like comparatively the throat is so hot compared to the liquid nitrogen that it just creates the pocket of gas that lets it pass through. Yeah, it just goes right through. So I'm pretty sure you could get it into your stomach. The hard part would be though when your throat has to close off and squeeze it down into your stomach. That wouldn't be able to stay closed because it would puff up with the nitrogen gas that's expanding, and either it would go down into your stomach or out your mouth. So I say getting into your throat is fine because it passes through it just fine. See, it's down on the plate here. This is called the Leidenfrost effect. Essentially, it creates a pocket of shielding gas as it goes through it. Okay, but then the worst part would be if you could get that gulp of liquid nitrogen down into your stomach in a closed environment. Nitrogen expands very fast, especially when it's surrounded by warm stuff. Let's surround our liquid nitrogen with warm stuff. Here's some warm water I'm gonna pour in. 3, 2, 1. Whoa! And that would be your stomach. So I would see a major exploding stomach happening if you could get a big gulp of liquid nitrogen. Thanks for watching another episode of the Action Lab. If you're not subscribed yet, hit that subscribe button and be notified when my latest video comes out by hitting the bell button. And if you have any questions, let me know in the comments section and I'll try to get to them, and I'll see you next time.